Module 1. Lecture A, Introduction to the course. If you've ever written Python code that works but slows to a crawl as your data grows, this course is designed to change that. In Master Python Algorithms, you'll move beyond trial and error coding into deliberate, performance-aware problem-solving. You'll start by treating algorithms as clear, language-agnostic recipes, then connect those ideas directly to real Python implementations, so you can see not just what your code does, but how efficiently it does it, and why that matters as inputs scale. Across 10 focused modules, you'll build a toolkit step by step. You'll begin with algorithmic thinking and complexity, then learn to read and derive Big O, Big-Theta, and Big Omega for real Python loops and patterns. You'll connect that theory to Python's built-in data structures, lists, tuples, dictionaries, and sets, so you can predict their performance instead of guessing. From there, you'll implement and test core search and sorting algorithms, master recursion and backtracking, and then tackle greedy methods and dynamic programming on problems like coin change, knapsack, and edit distance. You'll round things out with graph modeling and BFS, DFS. And finally, you'll integrate everything into robust, Pythonic solutions with clear structure, tests, and lightweight benchmarks. By the end, you'll be able to look at a problem, choose appropriate data structures, and decide whether a greedy strategy, dynamic programming, backtracking, or graph search is the right fit. Then implement it cleanly in Python. You'll know how to reason about time and space costs, interpret timing experiments, and refactor naive solutions into scalable ones with confidence. Most importantly, you'll come away feeling equipped to tackle new algorithmic challenges on your own, with a clear mental framework instead of memorized recipes, and code that you trust to stay fast and maintainable as your projects grow. Thank you for your attention. See you all in the next lecture.